As we start chemical bonding and look at chapter 7 and 8, we're just going to have a quick video to refresh ourselves on some Chem 1 stuff and introduce one or two new ideas setting the stage for what we'll be talking about. So chemical bonds occur when two atoms come together and do something with their electrons that cause them to stick together. So we looked a lot at atomic properties in the last chapter and thought about the periodic trends. But what we're looking at here is we're looking at, instead of just one atom and what it's doing with its protons and its electrons and how much space they're occupying, we're seeing what happens when these two things come together. So if it was one atom by itself, the only attraction and repulsion we'd be dealing with would be the nucleus to its own electrons. But when we have two atoms that are close enough to interact, what happens is there's some repulsion from this nucleus to that nucleus, wanting to keep those two atoms apart. There's some repulsion between the electrons here and the electrons here, wanting to keep those two atoms apart. But the important thing, or the thing that allows us to make the bond, is that this nucleus is attracted to these electrons, and this nucleus is attracted to those electrons, and the electrons back to the nucleus. So at different distances, those attractive forces and repulsive forces are kind of pushing and pulling, if you will, to see which one's stronger. So the x-axis here, it's not labeled super well, but it has that R. In this case, that represents the distance between the nuclei. The y-axis, I believe I cut the label off of this, it would be potential energy. So up here's a high potential energy, and as we go down, here's our place of lowest potential energy. But what happens as these atoms creep closer and closer together is that attraction from the one nucleus to the other electrons and back, and then the other nucleus to the electrons and the electrons back to the nucleus, it's able to increase as they get closer and closer and closer together, until there's a point where we have kind of maxed out the amount of attraction that we can have. And the reason we're maxing out the attraction, or maybe not maxing out the attraction, but maxing out the stability, is that those nuclei get so close together that they start repelling each other even more. And the electrons start occupying space very close to one another, and they start repelling one another as well. So when our attraction's big enough and our repulsion small enough, we'll have a bond. And when we kind of maximize the attraction while minimizing the repulsion, we get into this really low potential energy state where it's most stable, and that's what a bond is. And the exact way that that happens, whether it has to do with sharing of electrons or gaining and losing, and what that's going to mean in terms of the structure, what that's going to mean in terms of the properties, is based upon the types of atoms and their chemical, but more importantly, I guess, at the atomic level, their physical properties. Electronegativity, ionization energy, electron affinity. So the differences there are based, I guess, manifest themselves as three different main types of bonding: metallic, ionic, and covalent. All things that we looked briefly at, some in more detail than others, in first year chemistry, and we kind of have some general rules here. And these are the rules from first year, that this is just a metal with a metal, that the electronegativity difference is bigger than this or smaller than that. When really, there's not a strict line between some of these. You can, in metallic bonding, have some metalloids. You can even get some nonmetals like carbon is involved in compounds like cast iron. Sometimes there's polar covalent compounds that act more like ionic, or things that we would expect to be ionic because it's a metal with a nonmetal, that are really sharing electrons more than they're gaining or losing of them. But these are general guidelines and good places to start, as long as you understand that they're not super strict rules. But the thing that's causing all of this to happen is that lowering of potential energy, and what's lowering that potential energy, or what's interacting mostly, is the nucleus with the valence electrons. Those electrons in the highest energy levels, those are the ones that are gained and lost in ionic, shared in covalent, or freely moving around in metallic. And these atoms gain, lose, and share electrons to have the same number as a noble gas, to have that full energy level where attractions can be maximized, repulsions can be minimized, and the atoms are in the place of lowest potential energy. So we think of that in terms of octets, normally having 2 s electrons, 6 p electrons, sometimes the d and even the f sublevels are also full. But it's not just about wanting to gain and wanting to lose, it's about the energy that's being exchanged as that happens. And that's what we'll add on or think about more correctly than we did when we were looking at this in first year chemistry.